you're going to be asked to order decimals, fractions. Okay, so we went through all those different strategies with that. And then we're going to be asked to think about the number line in number sense. Okay, so we have two fractions, and we're asked what a certain distance is between them. So I'm going to ask, so how would you find a number halfway between 1/4 and 5/4? Okay, so I want you to draw a number line and see if you can just make sense of this. And this could be 1/4, 2/4. Okay, so see if you can just make sense of this and just approximate. Okay, so try to find a number halfway between, so right in the middle of 1/4 and 5/4. So we have 3/4, 4/4, and 5/4. So we have, how did you find it? This is kind of a simpler example, but to be able to understand the pattern of what you did is going to help you with maybe a little bit more different ones that don't have a common denominator. So how did you find that? Yeah.
Well, you kind of find the mean too. That's your.
Okay. So you found the mean of what numbers? So meaning like the numerator, denominator?
More of the.
So it's okay. I'll give you the mean. So the mean is the average, right? So the average of the 2 points, so you can kind of reason through and see what that average is, just kind of looking at it, right? You could also average it, actually take the average. You have a common denominator. What is the distance between 1 and 4? Or what is the distance between 5 and 1? 4. Okay, so you can take the average of the distance. So we have a distance of 4/4 here. So what's the average? Well, the average of 4, the middle is going to be 2. Okay? Or 2, the distance of 2. Okay, so we have right here, so you have 1 and 5. So the distance of 2 distances away, or 2 1/4 away, is we go 1/4, 2/4. 1/4, 2/4. And that's your halfway point, is 3/4. Okay? So, how would you find the halfway point between 2/3 and 7/6? See if you can reason that out on a number line. They're different denominators. Maybe a little bit different. Okay, so this one's a little bit different. What are you guys doing for this one?
Changing the 3 to a 6.
Okay, so we first want to change the 3 to a 6. What's the distance between 2 and 7? Okay, we have 5. So what is the average of 5?
I have to change the top though, Jenny. Times.
So you say you want to change the top?
No, of the 2. You change the bottom.
Oh,
to a
4, 6, right?
So it's a 4.
Thank you. 4, 6.
So then you just 5, 6, 6, 6.
Okay, so we have 4, 6 here. 7, 6 here. So we go 1 6 away is 6 6. We go 1 6 away, that's 5 6. Now we know it's somewhere in between here. Does that make sense? We subtracted those 1 6, but we still are trying to find this middle point. So it's in between 5 and 6. So it'd be like 5.5, but it's a fraction. So it's 5.5 over 6. That doesn't make much sense, right? So what if we were to convert this denominator so that this top was not a decimal. Because we don't mix decimals and fractions together. Does that make sense? So what can we multiply on the top? And the same number to be multiplied on the bottom, so we get a whole number here.
10.
It could be 10. It could be, what's the smallest number? 2. So 5.5 times 2 is 11. 6 times 2 is 12. Okay? So that would be 11 12ths. So that's just a way to reason through it. Yeah?
Can you, I don't know if this works, it's worked on the last two, but can you add the fractions together and then divide them by 2?
Yeah, you can. So that's another strategy. So instead of just looking at the distances, let's do that for another example. So yeah.
Another question. Can you just move the decimal over 1?
So you said 5.5, move it over to the right or the left?
To the right.
To the right, so it's 55 over 6?
Yeah, and then so then you need the 6, so yeah.
Yeah, absolutely. Because that's multiplying by 10, right? That would be your operation. So then it would be 55 over 60, which would be the same as 11 over 12 in your calculator. Okay, so there's a lot of ways to do it. Notice there's a lot of ways. So let's do it this way with the 1/2. Okay? So we have, let's come up with a number. Say a fraction. Any fraction.
2/3.
2/3 and a fraction bigger than that. 5/7. Okay? So let's check this really quick. If we do a common denominator, multiply this by 7, and this by 7, we get 14 over 21. Multiply this by 3, we get 15 over 21. So it is actually larger. Okay, so we have that. So now we want to find the distance halfway in between. So go ahead on your paper, see if you can find the halfway between by just dividing it by 2 after you've added them together. See if that works. And then compare it with the way we've been doing it before, the number line way. So 2 ways I want you to do it. Adding them, dividing the fraction that you've added together by 2, and then doing the number line way. Okay, can someone come up and do the number line way? Or just attempt it if it's too messy? Someone come up and do the dividing by 2 way. Yep. One person, are you dividing by 2 or number line? Okay. Number line way.
Well, the number line way.
So I did do the dividing of that.
It's kind of confusing.
Well, because you get 14 over 21 and then 15 over
Like
21.
I
So
find
now
the
it has to be between those.
numerators.
Okay, so that'd be the 14.5 again, right?
Yeah.
Like middle numerator
Okay.
would be on top. And then like to make it not a decimal, you just multiply by 2. Which would give, that's like the lowest fraction.
And then I just want to decimal place number. And then reduce. Like that.
Okay, so talk out each step of what you did out loud.
So we found a common denominator, and then I just added the fractions, and well, I should have put that other step in there, but it was 29 over 21, and then I divided the top by 2. Well, I guess, okay. And then I just moved the decimal place over 1, and then just reduced 10.
Okay, so you added them. You got 29 over 21. You divided 29 over 21 because that's the average, right? They added the top, and then you did the average to find that midpoint. And then what did we do from here to here?
I moved the decimal place over, because
Okay.
I didn't know what times it
So you
was.
multiplied by 10.
Probably just by 2, but...
And then reduce. Yeah, perfect. So you may be noticing this may be the easier route to go. Alright, so one thing I want to talk about as we're going through, as we're seeing what's half of this fraction, we think about the number line. Brother Piper wanted to make sure that we went through what's called the density properties of rational numbers and real numbers. Okay, so we have those rational numbers being fractions again, can be written as a fraction. Okay, so say we have a number line. We found, say we had 14 over 15, 14 over 21, and 15 over 21. And we were able to find the halfway point. That means there's another number that exists on this line, right? So what if we were to say, okay, that's 29 over 42. That's the halfway point, we found that. What if we were to find the halfway point of this? Could we do it? Yeah, just the same way. What if we were to find the halfway point of that? We could keep going on and on and on. Okay? So the density, meaning the density property of those rational numbers, mean that you can keep dividing or keep finding a number that's smaller or in between those. Okay? And that's why the rational number line is countably infinite. Okay? So, in your homework, you're going to have to talk about countably infinite of rational numbers, irrational numbers. And basically what that means is that you can pair another number up, a number in the setup, with another number. Okay, so if we have whole numbers consist of what? 0, 1, 2. So whole numbers, you have the 0, right? Whole numbers consist of those. And if you were to pair it with another set of numbers, say the integers start with negative, very big number. Okay, it goes on forever in this way. But if we were to just start with, say, negative 1, 0, 1, 2, we could have a pair. We could always pair up a number. Okay? And you're going to have to see if this works out. But this is just an example of pairing these two numbers in each set. And that means they're both countably infinite. Okay, this is a big concept to wrap your head around. But basically, who knows what an equivalent set is? You guys have been talking about that. And the cardinality of the set, right? We can find out the cardinality of a set, or we can find out that it's equivalent if we know the cardinality is the same. We may know that these are going on forever and ever, but the reason why we know it's equivalent is because we can pair it up. So if you think of that pairing property, you'll be able to go through your homework and look and see how you would do that. Okay? Like I said, Brother Piper's going to be out of town, so if you want to email me, go ahead. My name is Gabby Lipke, and I appreciate you guys working with me. Let me know if you have any questions about the class. Have a good day.